So very good afternoon to all dear students in this class on network analysis and synthesis. Just a minute. I think few more students are waiting. Okay. So is my screen visible to everybody?
Yes, sir.
Okay. Let us start now. So very good afternoon to all of you. Today we have third class on network analysis and synthesis. So in the last class, we had closed our discussion with KCL. So today we will continue with our next topic, and that next topic is our KVL, that is Kirchhoff's voltage law. So dear students, all of you already have studied about this basic concept, but just to reinforce those concepts, I am revising those basic topics that you have studied in basics of electrical engineering, and that reinforcement is very very important because this subject, foundation of this subject is based on these basic concepts. So as we discussed in KCL also, the KVL, that is Kirchhoff's voltage law, is also named after Gustav Robert Kirchhoff. Okay, and in the KCL, we had discussed that some of the currents is zero at a particular node. In the same way, in the KVL we define that the algebraic sum of voltages around any closed path is zero. So dear students, the KCL is applied at a node. Node is a junction where two or more network elements they meet with each other, whereas your KVL is applied in any closed path. So in any circuit, all of you know, you see to the circuit shown in the left hand side, this is a closed circuit, or you can say closed path. And we have already defined what is the meaning of path and what is the meaning of closed path. So if we go about a closed path in a particular direction, mind one thing, we have to go in a particular direction. You see the arrow that I am showing, we are starting from one point and we encircle the closed path in a fixed direction, either clockwise or anti-clockwise. So in figure I am showing it as your clockwise direction. So keep this thing in mind, dear students, that we have to basically choose one fixed direction. You make it a point whether you will be going in clockwise direction, whether you will be going in anti-clockwise direction, and then always whenever you traverse a path, you go for that direction. I will advise you people that you go for clockwise direction, because we are in a habit of looking at things in a clockwise fashion. So from my side, I always adopt a clockwise direction. So you can see here that when we move around a closed path in clockwise direction, then we basically notice the voltages that we encounter across that closed path. Okay, now you see here that one important point that you have to keep in mind, as it is written in your slide also, that in case of any closed path, we will mention the voltages present in each of the circuit element. You can see here in this circuit that we have in the element 1 voltage V1 is shown, in element 2 voltage V2 is shown, in element 3 voltage V3 is shown, and along with voltages their sign is also indicated. V1 plus upward, then one is in the downward direction, then V2 is also associated with plus minus sign, then V3 is also associated with plus minus sign. So you you basically take care of this point, that wherever you start from, if you enter into positive terminal, you will take that voltage as positive, and if you enter into some element from its negative terminal, you have to write that voltage as negative. So if we start from element number 1, you can see, you look at the mouse, like if we start entering into element 1, we are entering from the negative side, so that's why this voltage will be taken as minus V1. You see in the equation, minus V1. Then we move forward, then as we enter into element 2, the voltage sign is plus, so we write plus V2. If we move forward, and if basically we reach element number 3, we enter into negative sign and we write it as minus V3. So, and then we reach at the same place where we started from, and then we stop there, and then we can say that the algebraic sum of voltage is so written that is equal to 0. So in this case we get minus V1 plus V2 minus V3 is equal to 0. Okay, Ritik, did you understand?
Yes, sir.
Okay, so just a minute. So now let us move forward. So after we have discussed KVL, then we will take one example on KVL. Yeah, Ritik, want to say something?
No, sir.
Okay. So we will now discuss KVL with the help of an example. So only then our concepts will be clear. This is one circuit. In this circuit, this is called single loop circuit. So we have already talked about loop. Loop is a closed path. So this circuit is a single loop circuit, means we have only one closed path. And in this question, we have to find Vx and we have to find Ix. So you look at the circuit, what we have done, this is a single loop circuit. We'll be applying KVL in this circuit. Okay, we have three network elements in this circuit. There are two voltage sources and one is resistance. Okay, so since the two voltage sources, their voltages are shown, and then we have resistance. So across the resistance, we have indicated the plus minus Vx voltage. Now again, as I told you, we will go around this single loop circuit in clockwise direction, and we will start writing the KVL voltages. So okay, I'll unmute some of you, and then I'll inquire whether you have understood this thing or not. Aditya, please unmute yourself. Aditya Jangra. Aditya is there? Okay. Akshay, unmute yourself. Akshay. Anisha, unmute yourself. Anisha.
Yes, sir.
Yeah. Beta, can you explain how we obtained this KVL equation that I have highlighted?
यस सर. सर इस लूप में जब क्लॉकवाइज जाएंगे तो सबसे पहले जो 7 वोल्टेज वाला सर जो वोल्टेज सोर्स है उसमें नेगेटिव साइन पे सर मीटर हो रहे हैं. तो -7 एंड देन आगे गए तो सर Vx की जो पोटेंशियल का जो साइन है वो पॉजिटिव है. पॉजिटिव से एंटर किया तो प्लस Vx
Okay.
And then sir 5 voltage sir minus से meet किए हैं तो sir -5 will be equal to 0.
Okay, yeah, good. You understood this thing?
Yes sir.
Fine. And dear students, यहाँ पे एक बात और है, like we are representing Vx with plus sign on the upper hand side and minus sign on the lower hand side. You could have represented in reverse way also, like you could have write minus upwards and plus downward. In that case, the value of Vx will come out to be minus 12 volt. So that way you are flexible enough to represent, but some common sense you have to apply while representing voltages. Since you are taking current in the clockwise direction, so obviously 100 ohm के अंदर जो current enter करेगा वो ऊपर से करेगा, और जब current ऊपर से enter करेगा तो according to our sign convention, the positive sign should come on the upper hand side. That's why we have taken plus on the upper side and minus on the lower side. Okay, so then now Anshul, unmute yourself.
Yes, sir.
Anshul, yeah. So beta Vx we have calculated, that is 12 volt. Now we
Yes,
need
sir.
to find out Ix. How will we do
Yes,
that?
सर V इज इक्वल टू आई आर होता है, तो आई एक्स जो है वो V बाय आर हो जाएगा ना, तो V
Okay.
12 है और रेजिस्टेंस और उसके अलॉन्ग वो रेजिस्टेंस की वैल्यू 100 ओम दे रखी है,
ठीक है,
तो वो 12 बाय 100 हो गया ना सर, तो 120 एम्पियर आ गया, 12 बाय 100 एम्पियर।
0.12 एम्पियर और 120
यस
मिली
सर,
एम्पियर।
0.12 आएगा, फिर उसको वो मिली
ठीक है,
एम्पियर में
गुड।
कैलकुलेट।
अच्छा मुझे एक बात बताइए, ये जो Ix का वैल्यू है ये 100 ओम में तो आ गया 120 मिली एम्पियर, बाकी सर्किट में ये जो 5 वोल्ट और 7 वोल्ट ये जो सर्किट एलिमेंट्स हैं इनके थ्रू करंट कितना होगा?
इनके थ्रू करंट सर, एक मिनट सर, सेम ही होएगा इनके थ्रू भी।
ओके गुड, यू कैन म्यूट योरसेल्फ
Yes,
बेटा। या अभिषेक मौर्य, अनम्यूट योरसेल्फ। अभिषेक, ओके। दीपक यादव, अनम्यूट योरसेल्फ। दीपक यादव, दीपम सरोज, अनम्यूट योरसेल्फ।
यस सर।
हाँ बेटा, ये बताइए कि जो ये करंट का वैल्यू है ये तीनों एलिमेंट्स के लिए सेम क्यों है?
सर क्योंकि सेम सर्किट है, एक ही सर्किट में सब कुछ हो रहा है।
अरे एक सर्किट में इसमें 5 एलिमेंट और भी हो सकते थे, सारे एलिमेंट्स में वैल्यू सेम थोड़ी होता। यहाँ सेम क्यों है? दैट आई एम शोइंग यू।
सर एक ही रेजिस्टेंस है।
बेटा इसका आंसर ये नहीं है एक ही रेजिस्टेंस है। जितने भी ये सर्किट एलिमेंट्स हैं, दीज सर्किट एलिमेंट्स आर इन सीरीज, and in series
Yes, sir.
current remains always same. There is no junction where current is getting divided. Okay,
Okay, sir.
so because of
Yes,
all
sir.
these elements in series, we are experiencing same current across all the elements of this circuit. Fine.
Okay.
Yeah,
Yes.
you can mute yourself. Fine, now let us move forward. So this is our second example on KVL, and in this example, just a minute, sorry. And in this example, we are taking the case of multi-loop. Okay, and here in this multi-loop, you can see that now we have put more than one loop here. Fine. So here you can see that we have to obtain VR2 and we have to obtain Vx. So if you look at this circuit carefully, what is happening? There are two loops, two closed paths are there. Okay, मैंने यहाँ पे 3 एरो से डायरेक्शन बनाया हुआ है, एक बार आप उसको ध्यान मत दीजिए. You simply see whether how many loops are there in this circuit. There are 2 loops. Okay, and here you see the voltage across R2 is VR2, the voltage across R1 is VR1, and yeah, then voltage between point A and B is voltage Vx, and we are supposed to find out two voltages, one is VR2 and another is Vx. Okay, now the first thing we need to find out is VR2. So you can very easily see that in the first loop, which is marked with green line. So if you apply KVL here, you will be able to straight away get the value of VR2. Let me, Kanhaiya, unmute yourself. Kanhaiya?
Yes, sir.
Yeah, better tell me, how will you obtain VR2 through KVL in the first loop?
सर क्लॉकवाइज जाएंगे तो -36 वोल्ट हो जाएगा एक तो।
ओके
सर प्लस VR2
ओके
सर प्लस 4 वोल्ट इक्वल टू 0।
यस, वेरी गुड। सो बट मुझे यहाँ पे एक बात और बताइए, VR2 आपने जो है KVL लगाया फर्स्ट लूप के अंदर, ओके, बट इफ यू लुक एट जो मेरा सेकंड ग्रीन लाइन है, सेकंड ग्रीन लूप जो मैंने शो किया हुआ है, अगर वहां भी आप KVL इक्वेशन लिखते तो VR2 आता वहां पे, आपने वो क्यों नहीं लगाया?
सर क्योंकि अभी फर्स्ट लूप से निकाल रहे हैं पहले हम।
नहीं, ऐसा नहीं है। देखो KVL का जो इक्वेशंस आप लिखेंगे वो लूप के लिए इंडिपेंडेंट होगा। तो बेसिकली अगर हम यहाँ पे देखें, ये जो मैंने सेकंड एनसर्कल किया हुआ है ग्रीन से, यहाँ भी तो आप KVL का इक्वेशन लिख सकते थे।
यस सर।
तो वो क्यों नहीं लिखा? कोई आंसर दे सकते हैं आप इसका? ओके, लेट मी आस्क समबडी एल्स। हिमांशु, रोल नंबर 24, अनम्यूट योरसेल्फ।
यस सर।
हाँ बेटा, मुझे ये बताइए कि VR2 फाइंड आउट करने के लिए जो मैंने सेकंड लूप शो किया हुआ है आपके सर्किट में, इसको यूज क्यों नहीं किया हमने?
सर अगर जैसे अगर मेनली जो VR2 की वैल्यू है, जो फर्स्ट लूप से हम कोई जैसे यहाँ पे कुछ और मान के वोल्टेज अंजप्शन करके वो आ जाएगी सर वैल्यू, फिर सेकंड लूप से निकाल लेंगे, फिर दोनों को ऐड कर देंगे सर, वो VR2 की वैल्यू होगी।
नहीं, ऐसा नहीं होगा। देखो, जो आपका सेकंड लूप है, अगर आप उसमें KVL लगाते, सेकंड लूप जो मैंने ग्रीन से मार्क किया हुआ है, सेकंड लूप में अगर आप KVL लगाएंगे, आपका इक्वेशन बनेगा
सर।
या
एक्चुअली मैं विशाल बोल रहा हूँ सर।
हाँ।
सेकंड लूप में हम KVL लगाएंगे तो वहां पे दो वेरिएबल ऐसे है जो हमें नहीं पता है।
एग्जैक्टली, सो दैट्स व्हाट आई वांट टू आंसर। वेरी गुड। व्हाट्स योर नेम? राहुल?
नो सर, विशाल।
सॉरी, विशाल। ठीक है, वेरी नाइस विशाल। इनफैक्ट आई वाज अबाउट टू आंसर दैट वे ओनली। यू कैन म्यूट योरसेल्फ। तो हिमांशु, एक्चुअली अगर हम सेकंड लूप के अंदर इक्वेशन KVL का लगाएंगे तो हमारे पास दो वेरिएबल जो हैं वो अननोन होंगे। एक वेरिएबल होगा VR2, ओके, एंड अनदर वेरिएबल भी Vx। तो अगर हमारे पास एक इक्वेशन है और दो वेरिएबल अननोन है, वी कैन नॉट फाइंड आउट द वैल्यू ऑफ VR2। दैट्स व्हाई हमने जो है ये जो ग्रीन से शो किया हुआ है, ये वाला लूप हमने कंसीडर नहीं किया। इज इट ओके?
ओके सर।
या सो हमें वो लूप कंसीडर करने हैं जिनके अंदर हमारे पास मैक्सिमम जो वैल्यूज हैं वो नोन हो और जिससे हम इजीली जो है आंसर को निकाल सकें। सो यू कैन सी हियर दैट बाय अप्लाइंग KVL इक्वेशन इन द फर्स्ट लूप we are able to straight away get the value of VR2. Now we have to find out Vx. So now in order to find out Vx, we have two ways to find out Vx. In fact, both the ways are shown in your slides. So let me ask some students if they can answer. Yes, roll number 28, Manish Raj, unmute yourself.
Yes, sir.
Better tell me, how will you find out Vx?
Sir,
Is the screen visible?
पर ऐसे Vx दिखाई नहीं दे रहा सर।
हाँ, Vx बताइए कैसे निकालेंगे?
सर विजुअल नहीं है ठीक से फिगर।
अच्छा, चलिए ठीक है, लेट मी आस्क समबडी एल्स। पारुल शर्मा, रोल नंबर 37, unmute yourself.
Yes, sir.
Yeah, Parul, you tell me, how will you find out Vx?
सर हम फिर से हम लोग KVL का यूज करेंगे।
Okay.
सर उसके थ्रू हम लोग पहले हम लोग क्लॉकवाइज चले दो पहले
नहीं
पॉजिटिव।
बेटा, फर्स्ट टेल मी वन थिंग, जो Vx है इट मे अपीयर इन मल्टीपल लूप्स। जो आपका मैंने सेकेंड लूप लिया है, जो मैं पहले बात कर रहा था, उससे भी Vx आ जाएगा। अगर आप थर्ड लूप की बात करेंगे, जो मैंने रेड से शो किया हुआ है, उसमें भी Vx है। विच लूप यू विल प्रेफर? एंड इनफैक्ट एक लूप और भी है जो आपका आउटर से, अगर मैं दोनों को मर्ज करूंगा, वो मैंने यहाँ पे शो नहीं किया है। लेट मी
सर
ड्रॉ इट। या
सर
हाँ, बोलो
हेलो
बेटा।
सर, ऑडिबल नहीं हो आप, रुक रुक के आवाज आ रहा है।
मेरा आवाज नहीं आ रहा आपको?
सर कट कट के आ रही है आवाज।
ओके, नाउ यू स्पीक आउट। इज इट ओके नाउ? हेलो?
हेलो
या एम आई ऑडिबल नाउ?
सर, एक्चुअली 2G पे नहीं सुन, सर आवाज बार बार कट हो रही है।
ओके, मुझे लग रहा है शायद आपका नेटवर्क जो है ना, उसका
सर
बैंडविड्थ।
एक्चुअली JNK में 2G चल रहा है शायद इसलिए।
ओके ओके, ठीक है
हेलो
बेटा। ओके, देन यू ट्राई टू लिसन, देन आई विल शेयर वीडियो आल्सो, आई विल आस्क समबडी एल्स। ठीक है। नेहा, रोल नंबर 33, अनम्यूट योरसेल्फ बेटा। नेहा, रोल नंबर 33। या नेहा, हाउ विल वी फाइंड आउट Vx?
Sir, we will apply KVL here in this
Obviously
loop.
KVL you will apply. Then in which loop you will apply KVL to find Vx?
In the bigger loop.
Okay, tell me the values.
So you are not audible.
I'm not speaking any. I'm saying that which loop should we use? Ritik, is
Yes,
Ritik
sir.
there? Ritik,
Yes,
am I
sir.
audible?
Yes, sir.
Clearly audible?
Yes, sir.
Okay, maybe like at students end there is some problem with the network. ओके, सो दैट्स वाई जिनके नेटवर्क में थोड़ा प्रॉब्लम है, शायद उनको वॉइस जो है वो प्रॉपर नहीं आ रहा है।
Yes, sir. हो सकता है उनके नेटवर्क में प्रॉब्लम हो।
ओके, लेट मी चेक विद सम अदर स्टूडेंट्स आल्सो। सुगंधा, आर यू देयर?
Yes, sir.
एम आई ऑडिबल?
Yes, sir.
इज देयर एनी प्रॉब्लम विद द वॉइस?
No, sir.
फाइन, देन रिया, एम आई ऑडिबल?
यस सर।
वॉइस इज कंप्लीटली ओके?
यस सर।
फाइन। सो डियर स्टूडेंट्स, अगर आपको वॉइस जो है मेरा वॉइस प्रॉपर नहीं आ रहा है, तो मे बी सम इंटरनेट कनेक्टिविटी इशू इज देयर फ्रॉम स्टूडेंट साइड। सो I had told you in the previous class also, I'll be sharing my videos which I am recording along with my delivery. Actually, I couldn't share earlier videos because I have to edit those videos a bit. So most probably within a day or two, I'll be sharing all my classes videos. So no need to worry about. So if my voice is not properly coming because of internet connectivity issue, that thing will be taken care of. Okay. So let us continue. So dear students, you see we can find out Vx here in two ways. You can take the green loop, okay? You can take the red loop, and you can take a bigger loop also. So here in the equation that is shown in your slide, we have considered the bigger loop. You look at the mouse closely. So wherever I am encircling this mouse, this loop we are considering to calculate Vx. So you see here, if we start enter into, let me use annotation, then you will be able to understand. Uh, See, we are starting with this point. We are entering into 4 volt. Then we are entering into 36, that is minus side minus 36. We are entering into plus 12. Then we have plus 14. Then we are moving into plus Vx. Okay. And then we are coming back to that 4 volt thing. So this loop we are traversing, and if we do that, you can say that we have all other values present with us, and we'll be able to find out Vx directly as 6 volt. Fine. There is one more approach. You could take uh, this path also, this one, which I am now showing. Actually, earlier we didn't know the value of VR2, but now we know the value of VR2. So if you traverse through this loop, then what will happen? We know the value of VR2, that is minus 32 volt. Then we move to plus 12 volt. Then we move to plus 14 volt. Then we enter into plus Vx, and then sum of algebraic sum of voltages is 0. You'll be able to find out Vx equal to 6 volt. So this is your second example that is related to your multiple loops. Okay. So now let us move forward. Yeah. So this is third example of KVL, where we need to determine Vx. So you look at this circuit. So in this circuit we have, again now we have 3 loops: one loop, second loop, and third loop. Fine. So here what we are doing, you look at the figure number B. So what we have done, we have indicated the voltages across each branch. The voltage across 8 ohm is V8, across 10 ohm is V10, then across 4 ohm is V4. Then we have basically assumed the voltage Vx across the current source, that is your Ix. So let us write KVL equations. So first we will write KVL equation for loop 1. So let us see how do we come across this thing. So you can see here, when we enter through 60 volt, we enter from minus 60. So that's why we have minus 60 volt. Then we move forward. We have when we enter into 8 ohm, we enter from plus V8 side. So we have the value plus V8. Then we enter into 10 ohm. From the plus minus V10 value, we get the plus V10. So if we take the algebraic sum of all these things, we come across minus 60 plus V8 plus V10 equal to 0. And similarly, uh, we will be basically obtaining the second KVL equation. So the second KVL equation, we have V10, V4, and Vx. So let us see which loop has been used here. So a bigger loop has been taken, and you can see this loop is being taken care of or considered here. So see, uh, we enter V10 from the downward direction, that is negative 1, we get minus V10. Then we have plus V4, then we have plus Vx. Okay. So if we take the algebraic sum, we get minus V10 plus V4 and plus Vx equal to 0. Now, in both these equation, if you look at, we have the variables Vx, V4, V10, and V8. So we need to find out the values of these variables, otherwise we'll not be able to find out Vx. So first we need to find out the value of V10. So let us see how can we find out the value of V10. So see, if you consider this loop, so in this loop, if you see, here, Just a minute. Just a minute, students. My mouse has stopped working. Okay. So you see here, we were talking about this equation, that is V10 equal to 0 plus 60 minus 40. So if we see here, what is the value of V8? The value of V8 is V equal to IR. The current through 8 is 5 ampere. So V8 is 40 volt. So you can see here in this loop, we have, you see this equation, first equation, we have minus 60 and V8 is plus 40 plus V10 equal to 0. So if you do that, the value of V10 will come out to be 20 volt. Is it okay? Ritik, understood?
Yes, sir.
Fine. Now after obtaining the value of V10, after obtaining the value of V10, now we need to find out the value of Vx. So how can we do that? So you can see here we have V10 available. Okay. Now we need to find out V4. Okay. So in order to obtain V4, we must be aware of the value V4 is equal to 4 into I4. So we need to calculate I4 first. Okay. And how can we calculate I4? See, we'll apply KVL here. Sorry, not KVL, KCL here. So what we'll do, in this node, 5 ampere is entering. Okay, I10 is the current coming out of this node, this I10. And what is the value of I10? I10 is V upon R, that is V10 upon 10 ohm. So you see this, V10 upon 10 ohm. And V10 value we have obtained as 20 volt. Okay, so your I10 will be 20 by 10, that is 2 ampere. So we have 2 ampere going out, we have 5 ampere coming in, so we'll be left with 3 ampere. So the value of your I4 will be 3 ampere. Okay. So if we get I4 as 3 ampere, then we'll get V4 as 12 volt. So if V4 is 12 volt, here 12 volt, so what will be Vx? Vx is 20 minus 12, that is your 8 volt. Is it clear? Is it clear? Fine. Now let us move forward. So next is your single node pair circuit. So here again we are taking one example which will make use of KCL and KVL. Okay, so we call it as single node pair circuit because we have these 4 elements connected to a single pair of nodes. This is one node. I told you in the previous class also. This is another node. So these elements, these 4 number of simple elements, they are connected between the same pair of nodes. So that's why we call these circuits as single node pair circuits. So what we have to do, we have to determine current in each element of this circuit. Okay, so straight away we can obtain the solution for this circuit. So yes, can anybody suggest me how have we obtain it. Yes. Sagar, roll number 50, unmute yourself.
Yes, sir.
Yeah, better tell me how could we obtain this equation? Minus 120 plus I plus 30 plus I2.
So first we make node at first we make principal node at first. पहले हम प्रिंसिपल नोड बनाएंगे, एक बेस नोड बनाएंगे. बेस नोड पे वोल्टेज 0 रखेंगे और प्रिंसिपल नोड पे वीए मान लेंगे.
अभी आप एक्चुअली नोडल एनालिसिस का बात कर रहे हैं जिसका हमने डिस्कस ही नहीं किया. आप टॉक अबाउट केसीएल.
यस सर, यस सर. मैं इस टाइप के क्वेश्चन में उसी से प्रैक्टिस करें, नोडल एनालिसिस से इजीली हो जाते हैं उससे.
ओके fine then. So okay, then I could understand that you already know about it. Let me give chance to somebody else. Sakshi, unmute yourself beta. Sakshi. Okay, Akhilesh, unmute. Akhilesh. Okay, Ritik, unmute yourself.
यस सर.
हाँ ऋतिक, बताओ ये इक्वेशन कैसे आया?
सर ये सभी सीरीज में ही कनेक्टेड है सर, देखा जाए तो.
सीरीज में नहीं है बेटा, दे आर इन पैरेलल.
सर वो एक्चुअली एक नोड तो इनकी प्रिंसिपल नोड बन जाएगी सर. ये ऊपर वाले जैसे एक नोड को हम कॉमन मान लेते हैं सर, ये सभी पॉइंट्स की एक नोड कॉमन हो जाती है सर. फिर इसमें हम क्लॉकवाइज चलेंगे तो पहले -120, फिर ये R1 में सर हो जाएगा +I1, और वहां पे 30 एम्पियर में सर फिर से +30, और R2 में फिर +I2 = 0.
ओके ठीक है. लेट मी एक्सप्लेन इन अ सिंपल वे. जो ऊपर वाला जो नोड है वहां पे हम केसीएल लगाएंगे. ओके, सो इफ वी अप्लाई केसीएल इन द अपर नोड, व्हाट वी हैव, 120 एम्पियर इज एंटरिंग इनटू इट. फाइन.
यस सर.
जस्ट अ मिनट. So 120 ampere is entering. So this is your -120. So
yes,
I1 is going out of this node. That's why +I1.
+I1.
So 30 is also moving away from this junction. That's why +30. Similarly, I2 is also moving out. That's why +I2. So there is only one incoming current. Rest are the outgoing current. That's why their sum is equal to 0. Fine. And now we will apply that thing you are talking about. What is I1? I1 is your, see, all these 4 branches are in parallel. और पैरेलल में है तो ये जो वोल्टेज V है ये चारों में V होगा. ओके, सो योर I1 will be V upon 1/30, that is 30V. Your I2, it will be, what will be I2? I2 will be V upon 1/15, that is 15V. So we will substitute these values here in this equation and you get V equal to 2 volt. Fine. And as a result, we are able to calculate I equal to 60 ampere and I2 is equal to 30 ampere. Fine. Okay. Now one question. Question is, can you tell me which current source is absorbing power in this circuit? Yes. Sugandha, are you there? Sugandha, unmute yourself.
Yes, sir.
Yeah. So you tell me, just a minute. You tell me which current source is absorbing power in this circuit. Yes. How will you be able to know whether a current source is absorbing power or it is delivering power? Yes. Sugandha?
Yes, sir.
Yeah. How do you know that a current source is or any power source is absorbing power or delivering power to the circuit?
Sir, I don't know.
Okay. No problem. Let me ask somebody else. Yeah. Vishal, unmute yourself.
हेलो.
Yeah. Vishal, tell me बेटा.
सर एक्चुअली ये कंसेप्ट मैंने पढ़ा हुआ है लेकिन सर अभी मुझे याद नहीं आ रहा है.
Okay, can you guess?
सर आई थिंक जो R1 है वो कम पावर एब्जॉर्ब करेगा।
नहीं, I am not talking about R1. I am talking about the current source. There are two current source here. One is 120 ampere current source, okay,
Yes, sir.
and another is 30 ampere current source.
Sir,
Okay.
just a second, sir. Okay, sir. I think, sir, 120 ampere.
Okay, it will be absorbing power or delivering power?
Sir, absorbing power.
No, no.
Sir,
Okay, let me ask somebody else.
Okay, sir.
No need to worry, I'll explain. Yes. Arpit, unmute yourself. Arpit. Arpit, unmute yourself.
Hello, sir.
Beta, can you
Hello.
tell me, yeah, what do you mean by when we say that a power source is delivering power or absorbing power?
Sir. Hello.
Yeah. Yes, Arpit, speak. Okay, Sagar, unmute yourself. Sagar, roll number 50. Okay, let me explain. Let me explain here. See, normally the purpose of the any current source or voltage source is to provide power to the circuit. Fine. So you can understand it like this. All of us, we have inverters in our home. Okay. So they do two kind of, you can say they perform two kind of functions. When we have power from powerhouse, then your battery through inverter keeps on charging. Fine. So it means it consumes power. It is absorbing power. And when your power from your powerhouse is stopped or it is interrupted, that inverter or that battery starts delivering you the power. So same is the case here. If your 120 ampere current source has current directed inside it, okay, then it will be absorbing power. And if we have the current direction from the current source directed out of that, then we will say that it is delivering power. So let me explain it in a way that like you'll be able to understand with the help of voltage source like this. If we have a voltage source, say we represent it with plus and minus. So if your current is moving out of this plus, if this is a voltage source, okay, and if current is moving out of that, you'll say that power is being delivered. Okay, and if current comes inside the positive terminal, then we'll say that power is being absorbed. This is the case with your voltage source. Now you see here, in case of 120 ampere, the current is moving out, and look at the voltage V. It is plus on the top side and minus on the bottom side. So this nomenclature or this convention is matching with what I have shown with the voltage source. It means that your current is going out of the positive terminal. Okay. So it means that 120 ampere current source is delivering power to the circuit. Now you see in the case of 30 ampere current source, here the current is directed downwards, whereas your voltage V, which is across 120 ampere, same voltage is being applied across 30 ampere also, because they are in parallel. So that way you can say that the direction of the voltage and the direction of the current, they are reverse of each other. And if that is the case, it means it is absorbing power. So here it is the 30 ampere current source which is absorbing power here. Okay. So this is one important concept that I wanted to tell you in this numerical. Okay. So let us now move forward. So this is very simple thing. In fact, just for the sake of completeness, I have included this slide here. Maybe some of you, if are not, you know, just want to revise this thing, then it will be revised for them. Okay. So if some doubts are left unanswered at the end of the class, we will again consider that. So let us now move forward. Fine. So here you can see here that. So here the first topic is your series and parallel connected independent sources. So if we have more than one voltage source, or if we have more than one current source, then what will be the case in case of any circuit? So if we have voltage sources in series, then those voltage sources in series, they will be added together. The algebraic sum of all those voltage sources will give us one equivalent voltage source. So you can see here that we have plus V1 plus V2 and minus V3, because V3 is reversed here. So that's why it can be replaced by a single voltage source, equivalent voltage source, I'll say, and the value of that will be V1 plus V2 and minus V3. So voltage sources, they are added together if they are placed in series. Similarly, your current sources, the current sources, when they are parallel to each other, they can be combined algebraically. So here you can see I1 upward, I2 downward, and I3 also upward. So you can see that the equivalent current source will be I1 plus I3, because they are in the same direction, and I2 will be subtracted. So we'll have equivalent current source as I1 minus I2 plus I3. Now the question from my side for you people is, can we connect? Here we are talking about voltage source in series. We are talking about current sources in parallel. Now what about voltage source in parallel? Can we connect ideal voltage sources in parallel? Yes. I'll ask Nishant, unmute yourself. Roll number 35, Nishant. Okay, Neha, unmute yourself. Roll number 34. Neha 34. Unmute yourself. Pranjali, roll number 40. Unmute yourself. Pranjali.
Yes, sir.
Beta, can you answer this? That what will happen if we connect ideal voltage sources in parallel?
So as we know that voltage remains same in when voltmeter is connected in parallel.
Yeah.
So sir, if we connect we connect voltage in parallel source, then I don't think there is any effect in it.
See, we can connect voltage source in parallel only when they possess same values.
Yes, sir.
Okay, so even if you connect two voltage source in parallel having different values, they will arrive at same value after some time. Okay.
Yes, sir.
So in parallel voltage will always be same, but here look, keep in mind the value, word ideal. So the ideal voltage sources can be connected in parallel if and only if they possess the same values. So 5 volt in parallel, because their ideal voltage value will not change. So you can connect only those ideal voltage sources in parallel which possess the same value. Okay. Fine.
Okay, sir.
So sorry, in the second question I mistyped it. This will be, can we connect ideal current sources in series? Okay. So this is some mistake from my side. So this will be some current sources. Fine. Current sources, and this will be in series. So the logic that I told you regarding your basically voltage source in parallel, similarly your current sources, because in series current is same, so your ideal current sources can be connected in series only when they have the same value of current. Fine. So now let us move forward. So this is a very simple concept you are studying since I think your 9th, 10th, 11th also. You already know that how can we combine the resistances. Resistances can be combined in series and in parallel. So if we have resistances in series, we simply add those resistances and we get an equivalent resistances. And if we have resistances in parallel, then the equivalent value is obtained by reversing the values of resistances and then adding them together. So next, just to revise your concepts, we have voltage and current division. So your voltage is divided in series, okay, and current is divided in the parallel resistances, okay. And we already know that just in the previous slide we have studied this, that your voltages remain same in the parallel, so obviously it will be divided in series. Similarly your current remains same in series, so it will be divided in parallel. So this is very simple voltage divider formula, you all know. That is, if you want to find out voltage across R1, and if you have the total voltage at V, so it will be R1 upon R1 plus R2. So जिस resistance के across आप voltage का value निकालना चाहते हैं, that resistance will be the numerator and the total resistance will be at the denominator side. In current, this will be reversed. So here you see, if you want to find out the current across R1 through current division, so then in the numerator R2 will come, and in the denominator the sum of resistances will be there. So you can compare these two and very easily make out the difference between the two. But keep this thing in mind that these two formulas are applicable for two resistances either in series or in parallel. But if you have more than two resistances in series or in parallel, then these two formulas will apply. So that's why I have shown you these uh, formulas for voltage and current division. Now, next very important concept, that is your mesh analysis. As I was discussing in the last question, some of the students, they started talking about nodal analysis. So we have two important concepts. One is nodal analysis and another is mesh analysis. Mesh analysis is derived from the KVL, whereas your nodal analysis is derived from KCL. Okay, so first we will complete mesh analysis, and then in tomorrow's class we will complete with your nodal analysis. And once we are over with this nodal and mesh analysis, then we will actually start with the content of the syllabus that is prescribed for this semester. So that was my aim, to cover few basic concepts. So before we start with mesh analysis, we need to understand the terminology related to mesh analysis. One is planar circuit. So your mesh analysis is applicable only to those networks or electric circuits which are planar. Now we need to understand what is planar circuit. Planar circuits are those circuits in which no branches passes over or passes under any other branch. So you can see in this circuit towards left hand side that these branches are crossing each other, okay, either passing over above each other or they are passing under each other. So this this circuit is not a planar circuit, whereas the figure drawn at the bottom, this is a planar circuit. So there is no overlapping of the branches and it can be easily drawn on a plane surface. That's why we call it as a planar circuit. Okay, so this is about your planar circuit. Now we need to understand what is a mesh. till now we have studied a term which is known as loop, and we have defined loop in such a way that a loop is a path, closed path, where we do not traverse any node twice. This is how we defined loop in our earlier classes. So what is mesh then? So mesh is a loop that does not contain any other loops within it. It means that we should not have any other sub loop within a loop. Then it will be called as mesh. So we can also draw an analogy here, that you must have seen windows in your house or in offices. So if we assume a multi-paned window, मतलब एक ऐसा विंडो मान लीजिए जिसमें काफी सारे आपकी जो हैं छोटी छोटी खिड़कियां हैं. So the boundary of each pane, जो आपकी छोटी खिड़कियां हैं, छोटे शीशे हैं, उन सबकी बाउंड्री जो है, that can be considered as a mesh. In the next slide I'll show you that what is the meaning of mesh, or what is the difference between a loop and a mesh. So let us move forward. This is how we define the difference between your mesh and loop. See, in figure A, so here if you see, there is no closed path. यहाँ पे आपने क्या ध्यान देना है कि जितना भी आपका ब्रांचेस है, these branches they are like shown, one in the dark shade and another in the light shade. So we are talking about the dark shaded resistances in a figure. Okay, so here in figure A you see there is neither any path nor any loop, because here all the resistances they are connected with a common node. Okay, so it does not follow either a path definition or a loop definition. Now let us come to figure number B. So in figure number B, there is no path. So if you can see here that if you try to traverse a path, so I told you that while traversing a path, no node can be traversed twice. So here this node is being traversed twice, so this is not a path. Now let us move to figure number C. Okay, so here you can see that there is a closed path. This is a closed path. Okay, we are not traversing any node twice, so this is a path. Okay, and path is a closed path, that's why we call it as a loop. Okay, but you see here that there are some loops, sub loops in between. जो मैंने ड्रॉ किया है ये आपका बड़ा लूप है. अगर आप छोटे लूप्स की बात करेंगे, दिस इज अनदर लूप, दिस इज अनदर लूप, दिस इज अनदर सब लूप, this is another sub loop. So we have sub loops within a loop, that's why it is not a mesh. Okay, similarly here, that this is a loop. Okay, but we have sub loops also. This is a sub loop, this is a sub loop, so it cannot be a mesh. Whereas this is a mesh. You can see here that this is a loop and there is no sub loop in between, so it can be called as a mesh. Similarly, this is also a mesh and this is also a loop, so there is no sub loop in this one. Okay, so let me invite some questions if anybody has up to this point. Yes, any student, if there is any doubt, he or she can mute and then ask question. Yes, I think somebody raised hand also. Yes, Sagar, do you have any question? So I have allowed you to unmute yourself. Yes.
सर जो फिगर बी है वो मैश है सर?
Just a minute. See, when figure B has no, it's not a mesh, because you consider this as आप इनको दो मत मानिए, ये इट इज अ, यू कैन से दैट दिस इज अ सिंगल सर्किट इन अ वे. Okay, like you look at the mouse, like this is a kind of 8 kind of thing, you can say.
Okay,
Fine.
sir.
So if we consider that, if it is if we are not considering it as a path, जब path ही नहीं मान रहे तो mesh होने का सवाल ही नहीं उठता, because the basic definition is path. Then path होगा तो loop होगा, और loop होगा तो mesh होगा. Okay.
Okay, sir.
Yeah.
सर पावर डिलीवरी और पावर कंजम्पशन का बता दो एक बार.
Tell me your name first. Sagar.
Yes sir.
Okay, what is the confusion, you tell me first. Yeah, Sagar, unmute yourself.
सर पावर डिलीवर होगी तब वोल्टेज राइज होगी.
No,
सॉरी पावर.
see, there are two things. Power delivery means like in a way you can say that जो capable होगा वो power deliver करेगा. Okay, means you can say the current will be coming out of a source if it is able to deliver power.
Okay sir.
And if current is coming inside the source, okay, from
sir.
the positive terminal, okay, then
Okay,
we say that power is absorbed by the source.
Okay sir.
Is it clear?
Clear sir.
Okay, तो मान लीजिए बैटरी है, फॉर एग्जाम्पल बैटरी
sir.
को हम चार्ज भी करते हैं और बैटरी हमें पावर भी देती है.
Yes sir.
तो अगर बैटरी के पॉजिटिव टर्मिनल से करंट बाहर निकलेगा, इट इज डिलीवरिंग पावर.
Yes sir. और
और जब
inside
हम
आ रहा
चार्ज
है
करेंगे तो पॉजिटिव टर्मिनल से करंट अंदर जाएगा,
तो कंज्यूम में.
यस, इट विल एब्जॉर्ब पावर.
ओके. तो सर आपने उसमें करंट के मेथड से एनालाइज किया सर्किट में.
उसमें जो मैंने वहां पे करंट सोर्स था. ओके.
यस सर.
सो वहां पे जो बेसिकली मैंने जो करंट सोर्सेज थे वहां पे हमने, लेट मी गेट बैक टू द स्लाइड दैट.
आपने क्लॉकवाइज मतलब एजम्पशन लिया कि करंट क्लॉकवाइज ही है.
क्लॉकवाइज नहीं था वहां पे, वही प्लस माइनस कन्वेंशन है वहां भी. जस्ट अ मिनट. हाँ, ये वाला था ना.
सर ये पावर कंजप्शन और उस पे था सर. ये तो सिंगल नोड सिंगल पे.
इसमें देखो आप, जस्ट अ मिनट, इसमें आप ये देखो, दिस इज, जस्ट लेट मी चेंज द कलर. दिस इज योर 120 एम्पियर करंट सोर्स.
यस सर.
ठीक है, और ये आपका 30 एम्पियर है.
यस सर.
और 120 के अक्रॉस जो वोल्टेज है वो देखो आप, ऊपर साइड में क्या है, पॉजिटिव. और जो 120 एम्पियर करंट सोर्स से करंट जा रहा है वो भी कहाँ जा रहा है, पॉजिटिव से बाहर की तरफ जा रहा है.
यस सर, बाहर.
तो अगर आप V को वोल्टेज सोर्स मान ले तो करंट का डायरेक्शन पॉजिटिव से बाहर जा रहा है.
यस सर, डिलीवरिंग है.
इट इज डिलीवरिंग पावर. इज इट ओके?
तो सर आपने करंट मतलब माना है ना कि मतलब बाहर ही जा रहा है, ये पूछना चाह रहा हूँ.
वो इसलिए माना है कि जो 120 एम्पियर के अंदर हमने करंट का डायरेक्शन
दे रखा है सर.
डायरेक्शन अपवर्ड दे रखा है.
ओके ओके ओके.
और जो 30 एम्पियर है उसमें डायरेक्शन देखो कहाँ है, डाउनवर्ड है. ओके
ओके सर.
या दैट्स व्हाई मतलब जो है इट इज कमिंग लाइक दैट. यहाँ पे मैं एक चीज और आपको बता देता हूँ कि ये जो V का वैल्यू हम कैलकुलेट कर रहे हैं, ओके, जो V का वैल्यू हमने कैलकुलेट किया है, मैं इसका एक मिनट कलर चेंज करता हूँ आपको. ये देखो V का वैल्यू कितना है,
2 वोल्ट.
2 वोल्ट. इसका मतलब जो हमने कन्वेंशन V का लिया है, इसका मतलब ये +2 वोल्ट है. ठीक है. अगर ये आता -2 वोल्ट तो क्या होता बता सकते हो?
सर रिवर्स हो जाता ऊपर नेगेटिव.
हाँ, उस केस में क्या होता, 120 एम्पियर जो है वो पावर को क्या करता, एब्जॉर्ब करता. और 30 एम्पियर पावर को क्या करता, डिलीवर करता.
ओके सर.
अंडरस्टूड सर. या सो दैट्स द कंसेप्ट. सो अगर आप साइन कन्वेंशन को केयरफुली ऑब्जर्व करके और उसके अकॉर्डिंग आप चलेंगे, अगर आपने सी सर्किट थ्योरी के अंदर ये बहुत अच्छी बात है, अगर आपने साइन कन्वेंशन गलत भी एज्यूम, गलत तो कुछ होता ही नहीं, अगर आपने डिफरेंट एज्यूम कर लिया तो 1 माइनस साइन विल कम और उसका इंटरप्रिटेशन अकॉर्डिंगली चेंज हो जाएगा.
यस सर.
ओके
ओके सर.
फाइन. सो एनीबडी एल्स, anybody is having any doubt in the topic that we have discussed till now? Yes.
Actually sir,
yeah,
सर विशाल सर,
या
जैसे
बोलो
अभी
विशाल।
आपने बताया जो 120 एम्पियर है वो तो अभी करंट को डिलीवर कर रहा है, मतलब पावर को।
हम्म।
और जो 30 एम्पियर है वो क्या वो भी डिलीवर ही कर रहा है ना?
देखो बेटा क्या है, बेसिकली जब हमारे एक से ज्यादा सोर्सेज हो जाते हैं सर्किट के अंदर, ठीक है ना, तो
यस सर।
उनका बेसिकली इक्विवेलेंट जो है सोर्स रिप्रेजेंटेशन हो जाता है, ठीक है। तो उनके अंदर जो डोमिनेंट सोर्स होगा वो डिलीवर करेगा, और बाकी जो है जो लेस डोमिनेंट सोर्सेज होंगे वो बेसिकली रिवर्स मोड में चले जाएंगे।
ओके
ठीक।
सर।
हाँ, और अगर उनकी डायरेक्शन सेम है, ओके, मतलब मान
यस सर।
लीजिए यहाँ पे 30 एम्पियर का जो डायरेक्शन है करंट का वो भी अपवर्ड होता,
यस
फिर
सर।
वो दोनों डिलीवर कर रहे होते।
यस सर।
ये इसी तरीके से हो गया। मान लीजिए आप किसी टेबल को पुश कर रहे हैं, ठीक है, और
ओके
जिस
सर।
डायरेक्शन में आप पुश कर रहे हैं अगर आपका छोटा भाई भी उसी डायरेक्शन में पुश कर रहा है तो आप ज्यादा पावर से पुश कर पाएंगे, ठीक है।
ओके सर।
और अगर आप ऑपोजिट डायरेक्शन में लग जाएंगे तो आप जो टेबल को पुश करेंगे वो आप दोनों का रिजल्टेंट लगेगा।
ओके सर, हाँ
तो
सर आ
उसमें
गया
क्या हो
समझ।
रहा है कि आपका जो छोटा ब्रदर है वो आपकी पावर को क्या कर रहा है, कंज्यूम कर रहा है।
जूम कर रहा है, यस सर।
सेम थिंग हियर।
ओके सर, ओके सर, थैंक यू सर।
अंडरस्टूड।
सर
यस
आपने
सर।
जो सर आपने जो पॉजिटिव नेगेटिव साइन कन्वेंशन लिए 120 एम्पियर में, तो ये सर
हाँ।
जो करंट की डायरेक्शन है उसके हिसाब से लिए हैं वोल्टेज की जो साइन कन्वेंशन है प्लस
नहीं
माइनस।
नहीं नहीं,
ये सर
सी,
साइन
ये जो
साइन
वोल्टेज का
कन्वेंशन।
साइन कन्वेंशन मैंने प्लस माइनस लिया है, ये मैंने मेरी तरफ से ले लिया कि ऊपर मैंने पॉजिटिव शो करना है नीचे नेगेटिव शो करना है, दैट्स इट।
ओके सर।
और मेरा एज्यूम करने के बाद जब मेरा आंसर पॉजिटिव आ गया इसका मतलब क्या हो गया कि जो मेरी कन्वेंशन है वो करेक्ट है।
यस सर, वो डिलीवरिंग हो गया।
हाँ, और
ओके ओके सर।
अगर मेरी वैल्यू आ जाती -2 वोल्ट, इसका मतलब जो मेरी कन्वेंशनल है वो अपोजिट है, मेरे को रिवर्स करनी पड़ती फिर वो
ओके सर, वो अपना आप हो जाएगा प्लस माइनस
वो
जो भी
अपने आप हो जाएगा
रिजल्ट।
प्लस माइनस।
ओके सर,
यस
ओके ओके,
यस।
थैंक यू।
या एनीबडी एल्स, एनी अदर डाउट डियर स्टूडेंट्स, एनी अदर डाउट? आगे चलें। ओके, लेट अस मूव फॉरवर्ड नाउ। Okay, so this is what we were discussing at that time. So I hope the difference between your mesh and loop is clear to everybody. So let us now move forward. So this is your mesh analysis technique. Okay, time is, in fact, we have already exceeded time, but I'll hurriedly finish off this mesh analysis so that topic is complete. Okay, so in mesh analysis technique, we define a mesh current. Okay. So now you can see in the circuit which is shown towards left hand side that we will basically you can, for the simple sense, you can assume mesh as a loop or a loop which does not have any sub loop. तो यहाँ आप देख सकते हैं कि आपके देर आर टू लूप्स और टू मैश। जितनी भी मैश आपको सर्किट में नजर आए, यू सिंपली इंडिकेट इंडिविजुअल मैश विद मैश करंट। ओके, आपने उस मैश के अंदर एक मैश करंट शो करना है विद अ कर्व्ड एरो। जैसे हमने यहाँ पे I1 के लिए एक कर्व्ड एरो शो कर दिया। वी हैव फॉर मैश 2 वी हैव शोन अ कर्व्ड एरो विद लेबल्ड I2। ओके, एंड अगेन I am in a habit of representing things in clockwise fashion, so that's why I have also taken here the direction clockwise. You may choose anti-clockwise, but I'll always suggest you that you go for clockwise direction only. और फर्स्ट ये करने के बाद इफ देर आर m meshes, देन इंडिविजुअल मैश के अंदर उतने ही मैश करंट्स हम शो करेंगे एंड those many number of equations we can write. And as I told you, mesh analysis is dependent on KVL equations. तो आपका जो है जितने आप मैश को रिप्रेजेंट करेंगे उतनी आपकी KVL equations बनेंगी। Okay, and we will write KVL equation for each mesh current. Okay, so how will we write? Then we will see it in the next slide. So I hope this convention is clear to you कि आपको सर्किट के अंदर जितनी भी मैश दिखाई दें, सारी मैश के अंदर आप एक क्लॉकवाइज डायरेक्शन में करंट्स को रिप्रेजेंट कर दीजिए, एंड देन यू राइट KVL equations for that. So let us move to next slide. So this is example number 1 for mesh analysis. Again, I am telling you that we have to be very careful for plus and minus sign while writing mesh equations. Okay, so you can see here that this is your circuit. So where there are two mesh. So this is one mesh, this is your second mesh. Fine. So in this mesh 1 we represent or we indicate I1, we take a clockwise direction. In the second mesh we simply, without giving a second thought, we represent with I2. Okay, now we have to write KVL equation. So let us start the nomenclature, sorry, sign convention that we assumed in KVL. The same thing we will write here. Okay, so what we can say here, as we are entering from negative voltage, we'll write -5. Now see, जैसे मैंने आपको कहा था कि ये जो I1 करंट है, दिस इज एसोसिएटेड विद एंटायर मैश. तो हमने ये देखना है कि इंडिविजुअल ब्रांच के अंदर कितना करंट आता है. नाउ 4 ओम के अंदर 4 ओम इज एसोसिएटेड विद ओनली मैश नंबर 1, only mesh number 1. So that's why the current through this branch will be 4I1. This is 4I1. ठीक है. Now let us move to resistance 2 ohm. इसमें आप क्या कर रहे हैं, इसमें आपका जो I1 है it is in the downward direction. ओके, और जो आपका I2 है, इस ब्रांच के अंदर दो मैश करंट, इट इज एसोसिएटेड विद टू मैशेस, मैश 1 एंड मैश 2. तो जो I2 है वो इट इज इन द रिवर्स डायरेक्शन. अगर आप क्लॉकवाइज डायरेक्शन में देखेंगे तो इसमें आपका जो नेट करंट है 2 ओम से, दैट इज योर I1 माइनस I2. आपको जिस मैश को आप कंसिडर कर रहे हैं प्रेजेंटली, उसको प्रेफरेंस देना है, उसके करंट को पॉजिटिव रखना है, और उसके अलावा जितनी भी मैश उसके साथ ब्रांच के साथ एसोसिएटेड है उन सबको आपने नेगेटिव लेना है. एंड देन इफ यू मूव टू दिस एलिमेंट करंट की डायरेक्शन में, तो आपका जो है ये -2 एंड दिस विल बी इक्वल टू 0. So this is how we write a mesh equation. I'll inquire from you people whether you have understood this or not. Just a minute. Yes, students, if there is any doubt, you can ask anybody. You can unmute yourself and discuss. Is this concept of I1 minus I2 clear? Ritik?
Yes, sir. Yes, sir.
I1 minus I2 is clear to everybody?
Yes, sir.
Okay. So
Yes, sir.
this is very important concept. जिस भी mesh को आप consider कर रहे हैं, उसके करंट को आप पॉजिटिव रखिए, और बाकी मैश के जो करंट्स अगर उस ब्रांच में आ रहे हैं उनको आप माइनस करके राइट कर दीजिए. नाउ लेट अस मूव टू सेकंड मैश. अब आप इसमें देखिए सेकंड मैश में वी स्टार्ट विथ हियर 2 वोल्ट. तो क्लॉकवाइज डायरेक्शन में जा रहे हैं तो +2 वोल्ट, दिस इज +2 वोल्ट. देन फिर हम इस 2 में गए, दिस 2 इज शेयर्ड बिटवीन 2 मैश. अब हम मैश 2 को कंसिडर कर रहे हैं, तो I2 इज द प्रायोरिटी. विल टेक V equal to IR. R is 2 and current is I2 minus I1. क्योंकि हम I2 को कंसिडर कर रहे हैं तो नेट करंट विल बी I2 minus I1. देन ये जो 5 ओम रेजिस्टेंस है इसके अंदर ओनली I2 is there. Then this +1 volt. So it comes out to be +2 I2 minus I1 plus 5 I2 plus 1 equal to 0. So what we have two variables and two equations. You can easily calculate the value of I1 and I2. Is this thing clear? Ritik?
Yes, sir.
Sugandha? Is it clear or any doubt is there?
No, sir.
Okay. Vishal, did you understand?
Yes, sir.
Okay. Deepak, you have raised hand. You can unmute and ask question. Deepak?
सर इसका आंसर गलत आ रहा है, I2 की वैल्यू कुछ और आ रही है मेरी तो।
हाँ,
I2 की वैल्यू सर कुछ और आ रही है।
I2 का कितना आ रहा है?
सर I2 की वैल्यू 0.84 आ रही है माइनस की। मैंने सर थोड़ा अलग मतलब अपने कन्वेंशन यूज करे हैं सर।
ओके, आप एक बार जो है ना ट्राई करना एंड स्टिल जो आप वर्कआउट करेंगे आप मुझे व्हाट्सएप करना अगर डिफरेंट आता है तो, ठीक है? मे
ओके
बी
सर।
मतलब जो है मैंने बुक से ये नोट किया है तो हो सकता है कैलकुलेशन मिस्टेक हो, बट स्टिल यू ट्राई वंस आफ्टर द क्लास एंड देन यू कैन डिस्कस विद मी. ओके?
ओके सर, ओके सर।
So this was the concept of mesh analysis, beta, and today we stop here with this mesh analysis. कल जो है हम लोग mesh analysis के साथ nodal analysis भी complete करेंगे, and with that your basic part will be over, and then we will start with your new topic. So I hope everybody understood the topics that we have covered, and if there is any doubt you can send me a message through mail also. You are added in Google Classroom. You can also send me WhatsApp message, then I'll try to answer all your queries. Okay, so thank you very much. So I pause here for today's class, so tomorrow we will again meet at the same time. Okay, thank you.